exponents. It's very easy to the exponents, not necessarily rules, and it can get really confusing, and it's really easy to kind of mix the rules together. Is the multiplication property. Okay. Times A, applying two things. For it to work, for me to be able to, like, they both must be x to some power. The exponents themselves do not have to be the same. You add them. A to the m plus multiplying variables, that base or that variable or whatever, all the way throughout. The only thing that you did was add the exponents. So 3. What is my base? 3. Stay a 3, but I'm going to add the exponents and get the ones that are all numbered times x to the 7th, x to the 11th. Very good. A more difficult one. The numbers in the front, your coefficients, really follow these exponent rules because they're not exponents. Whatever operation you're going to multiply those numbers like normal. So 2 times 4 is 8. Exponent rules. You add the exponents. Okay, then the x's, I can only combine x to the what? 5th. Y to the 6th. Very good, because this y right 1, a y with a 5, you add the 1 and 5. Any questions? A to the m power raised multiply a to the m. This is only you would raise that number to the exponent like a normal exponent. Okay. 5. So in this example, 5 is my A. So this would be 5 because it's m when you have exponents. So we do 3 times 4. X to the now this more difficult example, notice nope, so we just raise it to the 2nd power, which is what? What's 4? And then each variable, I'm going to multiply the exponents. 6th z to the 14th. Very good. A to the m divided by is what? Anybody know? the m minus n. Technically 3. So this is going to be 3 to the Alright. I honestly don't in terms of subtraction. I kind of like to think about it in terms of canceling out. 17th on top. Technically, that's 17 x's being multiplied. X times x times x, 6. I like to think of it in terms of canceling out. That will help you avoid negative exponents later. How many total are you able to cancel? You're able to 11. On a question like this, yeah, 17 minus 6. But when they get more complicated, and especially when you got negative, it just sometimes thinking of it as canceling out is easier. When you have numbers in the front, like this 3/9, we're not going to subtract those numbers because they're not exponents. It's a normal division. 1/3. Keep this whole thing a fraction. Don't put like 1/3 and then something beside of it. Make it one big fraction. Alright, I have x to the 10th on top, x to the 4th on bottom. How many x's could I cancel? 4. And I'm left with how many? 6 on top. So this is, you could write this as just x to the 6/3. Don't put 1/3 of it because it can be a little confusing if I'm looking at it. Is that x to the 6 in the top or is it in the bottom? I don't know. So be intentional about how you write it. Alright, the 0 property. A to the 0 equals 1. Anything to the 0 power is 1. It is not 0. So what is 100 to the 0 power? 1. X times y to the 0 power? 1. What's the answer to the last one? Nope. 5. Look, this right here is 1. I tricked you. 5 times 1. Now, if that 5 was inside of the parentheses, it would be 1. But only the a plus b is the 0 power. So it's really 5. Negative exponent property. A to the negative m. Does anybody know what that is? Nope. 1 over a to the positive m. If you have a negative exponent, you're not allowed to leave it negative. That would not be completely simplified. What you do is you move it to the bottom of the fraction and that exponent becomes positive. Or if the negative exponent started out in the bottom, you would move it to the top and then it would become positive. Now I'm going to kind of add in a second rule here. If you have a number in front of that a, that number stays in the top. The only thing that moves to the bottom of the fraction is the part that actually has that negative exponent. So if we have 2x to the negative third, is that 2 being raised to the negative third power? No. So the 2 stays. This way, is that 2 being raised to the negative third power? Yes. In that case, the whole thing would move. Alright, so let's do these examples. 5 to the negative second power is what? Yep, 1 over 5 to the second. We could go ahead and simplify that. We can do that easily. What is 5 squared? 25. So we could write this as 1 over 25. X to the negative sixth is what? 1 over x to the 6. Very good. Here we do have a division problem. So 16 over 2 simplifies to what? 8 over 1, yep. Both of these x's have a negative exponent, so I have to move both of them. It's going to come, yep, you're going to swap them, but doing so makes the exponent positive. If you swap them and leave the negative, then you've just messed your problem up. Is my problem completely simplified? No. What can I do? Yeah, kind of. Think about it as canceling out your x's. Yep. So this would be 8 over x to the 8. You don't divide them by 2, but so you could think of it as the subtraction, the quotient rule, but I like to think of it as canceling out, and that's going to avoid having more negative exponents. Because you notice you had 8 extra on the bottom. I'll show you a brand new one. So anything, if you have a fraction exponent, that can be written as some kind of radical, some kind of root. So a to the m over n. Anybody that's seen this chart before, do you remember how I can write this as some kind of radical? It's the nth root of a to the m. Whatever your denominator is, that's the type of root that it is. So if your denominator is a 3, it's a cubed root. And then the top of the fraction stays with your base. So 36 to the 1/2 power. What type of root is this? It's a square root. You don't necessarily need to write the 2. So it's a square root of 36 to the 1st power. And what's the square root of 36? Just 6. If you type in 36 to the 1/2 power in your calculator, it'll give you 6. If it was the 1/3 power, it would be the cubed root. Alright, so x to the 5/7 is what type of root? 7th root of x to the 5th. And we just leave it like that. No, a root, a 7th root, you don't, it's not like division. It's totally different.
But like if you were to square something and then square root it, it would cancel out. That's just what I had.
Oh, yeah. But it would, they wouldn't cancel like in the fact of you wouldn't subtract them, it would literally turn back into x to the 5/7. Alright, so this would be the square root of 3x squared cubed. Back on this, if this was x to the 7th, then yeah, it would cancel out. That fraction would be 7 over 7, which would be 1. So really, it doesn't cancel. But is this completely simplified? No, I could simplify it more. What I would do what's on the inside. It is a, yeah, you can, if it's a second root, technically you don't have to write that, because on square roots we don't normally write a 2. It's implied. So what does this in underneath become? No.
3x to the 6.
No. 27x to the 6. Look back up here. Remember, the number that's inside is just a plain number. You raise it to that exponent like normal. So this 3 raised to the exponent. 3 to the third power is not 9. It's 27. 3 times 3 times 3. And then the x to the 6th. All right, now, there are some of these are not that challenging, but some of these 10 problems on the back are rather challenging. I want you to work on them, and then I will go over them. All right. Okay, number 1. Could you get number 1?
Yeah.
Okay, that was easy, right? Negative 35x to the 8th. Did everybody get that?
Yeah, pretty much.
Okay.
Something like that.
Number 2. 4x to the 6th y squared. Okay. Number 3. 18x to the 4th y cubed. If you had that over 1, that's okay. Are we good so far?
Yep.
Number 4, what did you put on that one? 10 over x to the 7th. Good, because remember that 10 does not have the negative 7 exponent, so it does not move. Now, number 5, you really needed to do that one in 2 steps. Some of these, you're not going to just be able to look at the problem as a whole and get to the final answer. So, the first step, I would do this part right here and get x to the 8th times 81x to the 4th. Negative 3 to the 4th power. Now, if you don't put negative 3 in parentheses, you get a negative 81. Yes?
So, if the squared is in the parentheses and the other exponent is on the outside, you have to multiply.
You multiply them. Yep, that's the power rule. Okay. This is really an x to the first, so that's why we do the 1 and the 4. 1 times 4, yes.
Would your x not be 4x?
Would what?
Your x not be 4x because it's x to the power 4.
Right here?
Your other one.
That one? It's x squared to the 4th, so you multiply 2 times 4. And there's really a 1 in front, so that would be 1 to the 4th power, which is still 1.
Why do you still put the 4 up and times it by 4?
Right here? Yep, that's x to the 1st to the 4th power. 1 times 4 is 4.
Why is it all these A's?
That's what takes it out of parentheses.
Yeah, we have, let me rewrite this. Okay, this is really x to the 1st. When you have an exponent to an exponent, you multiply them. What's 1 times 4?
Well, then why isn't it x to the 8th power, x to the 4th?
Because this had an exponent of 2, and you multiplied those. 2 times 4 is 8. This one, it was a 1 and a 4. So 1, 2 times 4 is 8. X to the 1st to the 4th, x squared to the 4th. Power rule says you multiply those exponents. 1 times 4. This will be x to the 2 times 4. Which is x to the 4th, x to the 8th. Alright, and so if here we multiply, this is really 1x to the 8th times 81x to the 4th. The numbers in the front, are they exponents? No, so you just multiply them like normal. So what's 1 times 81? 81. The x, here I'm doing x to the 8th times x to the 4th. I'm not doing x to the 8th to the 4th power. There's a difference. X to the 8th times x to the 4th. You add the exponents to get x to the 12th. The 4th power to get the positive. You multiply by 10x to the 7th plus 35x to the 8th. Can I combine these two? I can't add them because they are not like terms. Similar to this example we did first thing this morning. If they're not like terms, you can't add them. I'm done here. All right, number 7, we have a fraction. So I'm just going to rewrite a fraction to prepare my answer. 15 over 24 simplifies to what? 5/8. Okay. Don't think of the division with the exponents as in subtracting them. Otherwise, you're going to end up with some negatives and you're going to get messed up. Think of it as canceling out. If you have 10 x's in the top, 12 in the bottom being multiplied, and you cancel out, what's left? In the bottom or top? Bottom. So x squared. If you cancel out y's, what are you left with? Y to the 5th in the top.
I'll be keeping that close down.
God. All right, number 8. We ready? For number 8? Y'all got number 8?
Yeah.
Okay. Do this first part. We're raising to the 2nd power. Is this 5 an exponent? Nope. So you raise it to the 2nd power just like normal, which is what? 25. X to the 4th, y to the 14th, times. This one over here does not have an exponent at all. It's just 6x cubed y. Can I combine these? Yeah, I can multiply them. I could not add them, but I can multiply them. 25 times 6, 150. X to the 7th, y to the 15th. Very good. I'm going to skip number 9. We'll do that one last. Let's do number 10. What does this negative 1 exponent mean? It's going to move to the bottom. What's going to move to the bottom? The whole 2m squared. So this first m squared is staying. The 2m squared came down, and that became a positive 1 power, leaving a 1 in the numerator. What does a positive 1 power mean? It doesn't really do anything, right? So I can just multiply these, and I get 1 over 2m to the 4th. Any questions? All right, let's tackle number 9. We're not just going to get every piece of number 9 finished in one step. What is one thing that you can look at that you can do? This 4 to the 1/2 power, we know, I'm just going to put it up there, 4 to the 1/2 is the same thing as the square root of 4. Which is what? 2. So I know that is a 2. Is there anything else that you can look at right away and you know that you can change?
The x0 on the bottom is nothing.
Yeah. The x to the 0 really is just 1. It's like we're multiplying by 1, which truly is nothing. Okay. So I'm just going to rewrite what I know so far. 2x y to the negative third over 12 times 1 y z to the 2/3. I told you a couple of things. I told you you cannot leave negatives in the exponents. I told you you could not leave fractions in the exponents. So what's something else that you see that we could do?
Move the net y to the negative third to the bottom.
Yep.
But does that add your y's or?
Yep. So all of this on the bottom is being multiplied. Yep. So if I move that to the bottom, I have this y and also a y cubed, which makes me have a total of what?
2y cubed.
Y to the 4th. It's y times y cubed. Everything is being multiplied.
So when you move something to the bottom, it multiplies everything.
Yep, it's multiplying by whatever's down there. Yep. And so let's just fix that. 2x over 12. It doesn't matter which, if I put the y next, I'm going to y to the 4th, z to the 2/3. Okay. So everything down here is being multiplied. When I multiply by 1, you don't need to write that anymore. Okay, and then a y times a y cubed. I can multiply those by each other because they're both y's. Okay, anything else you see that we could do?
Third square root of z squared.
Yep, right here. So, yeah, z to the 2/3 is the same thing as the third root or the cubed root of z squared. So I'm going to rewrite that. Yep. And I can do one more thing, that 2 over 12 becomes 1 over 6. So problems like that look really complicated, and then rewrite it. Pick out another thing you can do. Rewrite it. Keep doing it until you think that there's nothing else you could do. Check everything.